In the desperate mid-war summer of 1943, the fate of empires rests not just on battlefield
From
courage,
the ice of the Eastern
but on
Front
industrial
to the sands
sinew.
of North Africa,
The Third
cost
Reich,
of the Third Reich's ambition
reeling
was
from the
absolute
catastrophe
defeat.
of Stalingrad and its expulsion from North Africa, has pinned its hopes on a new generation of Wunderwaffe miracle weapons. Chief among them, a 54-ton behemoth engineered for total domination, the Panzerkampfwagen Tiger. But here, far from the choking dust of the front lines, in the quiet, sterile laboratories of the School of Tank Technology at Chobham, England, a different, more forensic war is being waged. On August 22nd, Dr. Robert Stevenson, a quiet, methodical metallurgist, leans over a piece of captured steel. It is a massive transmission gear from a Tiger tank, 8 inches in diameter, 2 inches thick, designed to wrestle 700 horsepower from a complex Maybach engine to the drive sprockets. But this gear is a monument to failure. The gear tooth has not worn down. It has not cracked.
As you can,
It has been sheared completely off. A clean, brutal fracture through hardened steel that was supposed to be indestructible. This is not just a broken part. It is an indictment. This is not the first failed Tiger transmission Stevenson has examined. It is the 7th. A chilling, systemic pattern is emerging from the wreckage of the battlefield. Every single captured Tiger tank delivered to Chobham arrives with significant transmission damage, some minor, some catastrophic. This one is catastrophic. This gear was torn from Tiger 131, the famous tank captured intact by British forces near Tunis in May
constant torque placed
1943.
immense strain on the
The
interlocking
transmission
gears,
failed so
frequently resulting in
violently
critical
that it
transmission
locked the
breakdown,
drive
as
sprockets
indicated
solid.
here.
The metal fragments didn't just jam the gearbox, they shredded it. The tank, instantly immobilized, became a 54-ton steel coffin, a stationary pillbox, until it was abandoned by its crew. It is a prize of war, won not by an armor-piercing shot, but by a catastrophic mechanical flaw. Intelligence reports confirm this is not an anomaly. It is the norm. Tiger transmission failures are shockingly, unbelievably common. The statistics filtering back to Allied command are stark. More Tigers are lost to mechanical breakdown than to enemy fire. Of the approximately 1,300 Tigers produced by this date, fewer than half are operational at any given time. The rest are broken, awaiting parts, or simply abandoned where they stood. This is the central paradox of Hitler's supposed superweapon. On paper, the Tiger is the most formidable tank in the world, an invincible, unstoppable predator, armed with the legendary 88mm gun, shielded by 100mm of frontal plate, powered by a 700-horsepower engine. It is designed to kill any Allied tank at ranges exceeding 2 kilometers. In practice, the Tiger cannot even reach the battlefield. A staggering 50% of these machines suffer a major mechanical failure before completing their first operational mission.
As we can see, fully
Most
half
of
our
these
efforts
failures are
result
the
in failure.
transmission. Dr. Stevenson is the man tasked with understanding why. He is a metallurgist, not a soldier. Before the war, he worked for Vickers Armstrong, analyzing steel for naval construction. When war erupted, the War Office recruited him for a new shadow war, analyzing the enemy's armor, his weapons, his industrial DNA. He has seen the Panzer IEs and Panzer IVs, They are generally well-engineered, reliable. Their transmissions function, not the Tiger. The Tiger transmission is an unmitigated disaster. German designers, in their quest for an unbeatable weapon, had created a tank that the German transmission industry could not adequately support. The result is a weapon system that defeats itself. A multi-million Reichsmark investment that fails mechanically before it can even engage the enemy. Stevenson's job is to perform the autopsy. He begins with the failed gear. Under magnification, the fracture surface tells the story. It is a brittle fracture. There is no plastic deformation, no ductile tearing that would warn of a coming failure. Just a clean, sudden break. One moment, the gear was transmitting torque. The next, it shattered like glass. Stevenson moves to the Rockwell tester, pressing a diamond indenter into the gear's surface. The reading, 62 HRC, Rockwell C-scale. This is extremely hard. It is harder than specification. Transmission gears should be around 58 to 60 HRC, hard enough to resist wear, but crucially, soft enough to absorb shock and resist brittle fracture. This gear is a glass cannon. He tests multiple locations. The surface is consistently 62 to 64 HRC. He cuts the gear in half, a desecration of the enemy's finest steel, and tests the core. The interior measures 52 HRC. This confirms case hardening, a normal process where the surface is hardened for wear resistance, while the core remains softer and tougher. But the execution here is fatally flawed. The case is too hard, and it is also too deep, 4 millimeters deep, when the specification for a gear this size should be 2 to 3. This excessive depth and hardness make the entire gear brittle, a time bomb waiting for a shock load. Stevenson is beginning to see the ghost in the machine. To confirm his suspicions, Stevenson must go deeper into the very atomic structure of the steel. He needs to understand the microstructure. He painstakingly cuts samples from the shattered gear, polishes them to a mirror finish, and etches them with nitric acid to reveal the crystalline grain structure. Under a metallurgical microscope at 500x magnification, the truth is laid bare. The microstructure is dominated by martensite, a very hard, brittle phase of steel formed by rapid cooling from high temperature. Martensite is the armorer's double-edged sword. It provides incredible hardness, but at the cost of catastrophic brittleness. This is why tempering exists. Tempering is a secondary heat treatment, a gentle reheating to a moderate temperature. This crucial step allows some of the martensite to transform, to relax, becoming softer, tougher, and far less brittle. Proper tempering is what gives a gear the balance of hardness and toughness needed to survive the violent shock loads of a 54-ton war machine. This gear shows almost no sign of it. Stevenson sees vast fields of pure, untempered martensite. The steel was hardened, quenched in oil, and then, criminally, not adequately tempered. It was left in its most brittle, fragile state, ready to fracture under the first inevitable shock. This is not one faulty component. This is a conspiracy of failure. Stevenson examines the 6 other failed Tiger gears in his lab. All show the exact same pattern. Excessive surface hardness, dangerously deep case depth, a microstructure screaming of untempered martensite and brittle fracture. The problem is not isolated to one gear, one transmission, or one tank. It is systemic. It is a fundamental flaw baked into the Nazi war machine's most vaunted product. Every Tiger transmission rolling off the assembly line uses gears with inadequate heat treatment. They are all too hard, too brittle. They will fail under the stress of normal operation, and they will fail almost instantly under the extreme stress of combat maneuvering.
The failure began with
the
this
sharp
cog,
turns,
spreading
the
to
sudden
second,
accelerations,
and finally seizing
the
the
abrupt
third mechanism
lurching
entirely.
stops. These maneuvers create shock loads that spike far beyond normal operating stress. Properly treated gears are designed to absorb these shocks. The Tiger's gears cannot. They shatter. Stevenson, holding this evidence, understands he is looking at the Tiger's Achilles heel. It is not the 88mm gun. It is not the 100mm armor. It is a tiny, flawed heat treatment process in a factory hundreds of miles away. He writes his preliminary report, dated August 28, 1943. It is not a document of military strategy, but of cold, hard science. Yet, its implications are more explosive than a case of dynamite. The report documents the metallurgical analysis, describes the excessive hardness, explains the inadequate tempering, and, most critically, estimates the operational impact. The conclusions are significant and damning. Analysis of transmission gears from captured Tiger I tanks, he writes, reveals severe metallurgical deficiencies. Surface hardness exceeds specification by 10–15%. Case depth exceeds specification by 30–50%. Microstructure indicates inadequate tempering following
This is the critical section
carburization.
right here.
The resulting
operational
material
impact.
exhibits brittle fracture characteristics. He then translates this scientific failure into tactical reality. Estimated operational effect. Transmission gears will fail under shock loads encountered during combat maneuvering. Failure mode is catastrophic. Sudden fracture with no prior warning. Once fracture initiates, the transmission becomes inoperable. The tank is immobilized. This last word, immobilized, is the key.
Catastrophic.
He recommends immediate dissemination
Sudden
to
fracture.
Allied armor commanders. German Tiger tanks are vulnerable to mechanical failure. The report, marked secret, works its way up the chain of command, landing on the desk of one of the few men in the British Army who would understand its true value. Major General Percy Hobart, commander of the 79th Armored Division. Hobart is an iconoclast, an innovative thinker often sidelined for his radical ideas. He is the mind behind Hobart's Funnies, the specialized tanks that would later prove decisive on D-Day. Hobart understands that destroying an enemy tank is not just about firepower. It is about exploiting any weakness. He reads Stevenson's report and sees not a technical failure, but a tactical opportunity. If Tiger transmissions fail under stress, then Allied tactics must create that stress. Force the Tigers to maneuver. Force them to turn sharply, to accelerate and decelerate. Each lurch, each sharp turn, is now a bullet fired at the Tiger's brittle gears. Hobart circulates Stevenson's report to his armor commanders. The report includes a new addendum, a tactical recommendation that seems, on its face, absurd. When engaging Tiger tanks, attempt to force aggressive maneuvering, flanking attacks, rapid position changes, create situations requiring the Tiger to turn sharply or reverse direction. These maneuvers stress the transmission, may induce mechanical failure, A Tiger with a failed transmission is a Tiger removed from the battle without expending ammunition. The recommendations reach Allied field commanders in September 1943. The initial reaction is, predictably, one of profound skepticism. The idea that you can defeat a 54-ton heavy tank by simply making it drive seems absurd, even insulting. These are veteran commanders, hardened by the realities of armored warfare. Tanks are designed to move. Their transmissions are built to withstand maneuvering. This intelligence, born from a quiet laboratory, smells of wishful thinking. But the skeptics, facing the terrifying 88mm gun of the Tiger, the first validations come from the bloody, grinding attrition of the Italian campaign. In October 1943, British tank commanders in the mud and hills of Italy report unusual observations. Tigers, when flanked and forced into aggressive, pivoting maneuvers, sometimes just stop, not destroyed by gunfire, not burning, just lifelessly stopped. Their crews, realizing their mobile fortress has become a steel coffin, abandon them. Later examination by field engineers confirms the impossible. Catastrophic transmission failure. The pattern repeats, becoming a reliable, if quiet, tactical reality. In Sicily, in the brutal fighting around Monte Cassino, and later in the claustrophobic bocage of Normandy, Tigers are breaking down during combat at rates far exceeding any normal mechanical wear and tear. This is where Stevenson's data leaves the lab and becomes a weapon. Allied crews, emboldened by this secret knowledge, become more aggressive. They learn to bait the Tigers, forcing them to pivot, to slam from forward to reverse, to stress the very components that Dr. Stevenson had proven were brittle as glass. Each sharp maneuver is a roll of the dice for the German crew, a spin of the roulette wheel on their own drivetrain. The German after-action reports from this period are filled with confusion and frustration. They document the problem obsessively, mentioning transmissions failing during engagement. They attribute it to combat stress, to inadequate maintenance in the field, to the lack of spare parts, to driver error. They see the symptoms everywhere, but are utterly blind to the root cause. They do not realize the problem is metallurgical, that the heat treatment process in their own factories is fundamentally and fatally flawed. Back in England, Stevenson continues his analysis through 1944. He examines transmissions from Tigers built in different months, captured from different fronts, assembled by different factories. The pattern is consistent. A damning indictment of the entire German war industry. All show excessive hardness. All show inadequate tempering. The problem is not one factory or one bad production batch. It is endemic to Tiger production. This raises the critical, haunting question. Why would Germany, a nation of legendary engineers, a powerhouse of metallurgy and industrial science, build its most important transmissions with such a glaring, amateurish flaw? The knowledge to do it right existed. The capability existed. Why were the gears wrong? Stevenson investigates, reviewing captured technical documents, interviewing captured German engineers and factory managers. The answer that emerges is not one of engineering failure, but of systemic, ideological collapse. Germany is being crushed under intense production pressure. Tigers are needed desperately. Yesterday, on the collapsing Eastern Front, production schedules are compressed from realistic to hysterical. Albert Speer's production miracle is, in reality, a house of cards built on sacrificing quality for quantity. And the heat treatment process is a critical bottleneck. It is a slow, meticulous, scientific craft. Carburizing the gears takes hours, heating them in a carbon-rich atmosphere to infuse the surface, then quenching them in oil to achieve that critical hardness. And then, the most vital step, tempering. The slow, gentle reheating to reduce brittleness. Each step requires time, it requires furnace capacity, and it requires skilled, experienced workers. By 1944, the Third Reich is running out of all three. Time is a luxury the Reich cannot afford. Furnace capacity is pushed to its absolute limit, and the skilled workers have been conscripted, fed into the meat grinder of the front lines. They are replaced by forced laborers from occupied Europe and minimally trained personnel who do not understand the subtle chemistry of metallurgy. They do not understand that tempering is essential, that skipping it is not an efficiency, but a guarantee of future failure. They are ordered to follow simplified procedures: carburize, quench, ship. Tempering is skipped, or so abbreviated it becomes meaningless. It saves hours per gear. It boosts weekly output. It allows the factory to meet its impossible production quotas. The cost, of course, is reliability. The gears are hard,
Precision
but
and
they are
order in
brittle.
factories fuel
They
the
will
desperate
fail,
struggle raging in
but
the
that
East.
failure will
The cost
happen
is measured
hundreds
in
of
both
miles
steel
away
and blood.
in the field, not on the factory floor. The factory meets its quota. The transmission failure is someone else's problem. This is a pattern Stevenson sees repeated throughout late-war German production. Quality control is evaporating. The Tiger transmission is just the first, most dramatic example of an industrial base that is, quite literally, breaking down. After Germany's unconditional surrender in May 1945, the full scope of this industrial self-sabotage was laid bare.
Ja, Herr Offizier.
Allied technical intelligence
schrecklich.
teams,
Die Bomben fielen die
including
ganze Nacht.
metallurgists like
Wir haben alles
Stevenson,
verloren.
fanned out across the ruins of the Reich. They systematically examined production facilities, documented processes, and interviewed everyone from plant managers to slave laborers. The story of the Tiger transmission emerged in granular, damning detail. The gears were produced by multiple subcontractors. Zahnradfabrik, Friedrichshafen was primary, but also Maybach and other smaller firms. All faced the same relentless pressures. Produce more, produce faster. Quality was a distant, secondary concern. Workers described the environment. 12-hour shifts under constant threat. Minimal breaks, and production quotas that must be met. The heat treatment furnaces ran 24/7, loaded, quenched, unloaded, and immediately reloaded. There was no time for proper temperature verification, no time for adequate tempering cycles. A process that should have taken 16 hours was compressed to 8. The gears came out hard, yes, but fundamentally
Defiance in
wrong.
the face of
A
occupation.
post-war interview with
The
a Czech
Kotwica,
forced laborer
fighting
named
anchor,
Joseph
became a
Novak
symbol of the
revealed
Polish
another,
resistance.
darker dimension. We knew the gears were not right, he stated. We could see it in the color after quenching, but we said nothing. We were not German. Why should we care if German tanks broke down? Better that they break than kill people.
Is the
If we
rotating
did poor
platform
work,
secure for the opening tonight?
maybe the war would end faster. This was sabotage by negligence. Small, quiet acts of resistance, allowing the process to
Das
drift,
ist inakzeptabel.
not
Wie
reporting
konnte das
problems,
passieren?
not maintaining
Materialqualität ist
equipment
schlecht,
that
Herr Major.
accumulated into a
Ist der Zeitplan
massive
also wieder
degradation
verzögert?
of quality. The German supervisors and the Waffenamt, Weapons Procurement Agency, knew something was wrong. The flood of failure reports from field units was impossible to ignore, but the industrial system, gripped by the hysteria of total war and the ideological demand for numbers, could not respond. It could not slow down. It could not implement proper procedures. The pressure from Speer and from Hitler himself was relentless. More Tigers, more tanks, more production. The quality problems were acknowledged in memoranda, then ignored. The priority was the number of Tigers completed and delivered. What happened after delivery was not the factory's concern. By early 1945, Tiger transmission reliability was so abysmal that German tank commanders, the very men who were supposed to wield this invincible weapon, began requesting different tanks. They preferred Panthers, or even the obsolete Panzer IVs, anything but the Tiger. The machine that was supposed to dominate the battlefield had become a maintenance nightmare, a liability that consumed more spare parts and mechanic hours than it delivered combat victories. The problem was never fixed. It could not be fixed. The industrial system that created it was too rigid, too compromised, and too broken to reform itself. When the war ended, the Tiger transmission problem became a historical curiosity, a lesson for future designers. Stevenson's work, and the work of his colleagues, directly influenced post-war British tank design. When Britain developed the Centurion tank, transmission reliability was a non-negotiable priority. Heat treatment procedures were specified precisely. Tempering was mandatory. Quality control was rigorous. The hard-won lessons from the Tiger's failure were applied. Stevenson himself retired from government service in 1955 and took a position teaching metallurgy at Imperial College London. His students knew he had worked on wartime projects, but the details remained classified. He rarely spoke of it. The work had saved Allied lives, but it was built on a weakness born from German workers being exploited, from forced laborers pushed to their limits. The morality was not simple. In 1976, a graduate student named Thomas Richardson, researching tank reliability, interviewed the now 72-year-old Stevenson. When asked if he felt satisfaction knowing his work helped defeat the Tiger, Stevenson paused. Satisfaction? No, he replied. The Tigers were defeated by their own inadequate manufacturing. I just documented it. Someone else would have found the same problem. The problem was not lack of knowledge. It was a lack of ability to implement solutions. He saw it not as a victory, but as a recognition of systematic failure. This analysis is confirmed today. The Tank Museum at Bovington has Tiger 131, the only running Tiger in the world, the very tank whose failed transmission Stevenson may have held in 1943. The museum's engineers maintain it with painstaking care, using modern lubricants and avoiding the shock loads of combat. They know they are operating a machine with an inherent, fatal flaw. In combat,
Target is confirmed.
it would
We
fail,
move decisively through this
just
sector.
as Stevenson predicted. His analysis gave Allied commanders a vital psychological edge, the confidence to engage, knowing the invincible Tiger had feet of clay. Stevenson died in 1989. His obituary barely mentioned his wartime service. His true legacy was not in public fame, but in the archives. and in the institutional knowledge that prevents modern tanks from repeating the same fatal mistake. It is the quiet legacy of an engineer who understood that wars are won not just by courage, but by metallurgy.